I'm with Netflix. I'm a manager of encoding tools and technologies. I think we'll go ahead and get going as people are still coming in. I'm going to give a talk today, just a brief history of Netflix streaming, and I do mean brief because I've been at Netflix for about 5.5 years. And when I joined, we had a Internet Explorer plugin that was hosting Windows Media Player. We had about 2,500 unique titles. And the few reviews that were actually written on our streaming service didn't have much to say about it. But today, Netflix has more than 80 million active devices. We're on phones, tablets, game consoles, smart TVs. Pretty much if you buy a connected device, it's going to have Netflix on it. And certainly if you're going to buy anything, any Blu-ray player, any connected TV, anything at a store, it's always almost a given that it's going to have Netflix. In fact, Netflix is even starting to show up on remotes. So I'm going to walk through this last 5 years. It's actually kind of like my view of what happened because we stopped and looked back and said, wow, was that really just 5 years? And I'm going to talk about some of the major milestones of our streaming evolution. Oh, what did I do? I'm going to talk about some of the key codec and packaging decisions that we made, the evolution of our adaptive streaming model. And in there, I'm going to explain how we actually did iPad in less than 60 days, which was one of the more notable achievements at my time at Netflix. And I'm also going to talk about our move to a standards-based streaming model, which is where we are today. Very simple terminology as I'm walking through this. I'll be talking about muxed streams or multiplex streams, and that's simply audio, video interleaved in a single stream. And unmuxed streams would be a separate audio and video. I'll be using these rather frequently in the presentation. Just I think most people here know that, but in case you don't, that's the terminology we're using. So this is where we were 5.5 years ago, what I call a very humble beginning, because all that was Windows Media Player hosted in an ActiveX plugin that sat on Internet Explorer. It was, as I said, an ActiveX plugin, hosted Windows Media Player. We were using muxed audio video, which, no surprise, was Windows Media, VC1 WMA audio, using WMDRM in an ASF container. From there, we took it to an SDK, where we had the Roku One. We had a set of Blu-ray devices, connected Blu-ray devices, TiVo, and most famously, the Xbox. Our first Xbox release used the CE1 SDK, used those same streams that I just talked about. Our next step was the Silverlight player. The Silverlight player ran on PC and Mac, using Microsoft Silverlight, of course. We introduced A/B testing to our streaming client. We introduced adaptive streaming using unmuxed AV streams. So we had separate audio and video using play-ready DRM in an ASF container still. And we stuck an index at the front, and I'll explain this in just a little bit. And you're going to see this model a lot as we walk through our various devices. So this is how we did adaptive streaming in Silverlight. With the VC1, we encoded it into fixed size, closed GOP chunks, all the same across all bit rates, so that you could switch at any bit rate. We had an index at every stream. It was in the header that would give the client the ability to seek out, do range requests out to any chunk. We would select an audio stream based on the initial bandwidth, and the client would vary the video bit rate to manage the buffer. Looks something like this as you're walking through playback. Pretty standard today. In 2008, this was one of the early implementations. Now we had an interesting hack in Silverlight Player that plays a part in some of our future. And that was that Silverlight 2 did not allow HTTP 1.1 range headers, which were needed for range requests. Adaptive streaming, of course, is based on on range gets. Of course, chunk download requires the range request. The solution was what we call a range request in an URL. We worked with our CDN partners. We put some Python at the front, and we would insert range requests into the actual URL, and CDN would translate that and forward it to its back-end service as a real range request. So this is what a Silverlight URL looks like, even today. And you can see, rather than doing a standard range request, we simply insert range bytes in the middle. And if you notice, this is a signed you don't see everything, but there's a signed expiring URL, but it was all done such that we could stick those bytes in the middle and have a range request off of that. So this is how we did range requests in the Silverlight player. A few innovations on Silverlight. We implemented what we call the to-get rule, and that is that for all of our adaptive streaming clients, we want to play back as quick as possible. So we have a rule that you should be able to do start playback or get the information for a stream in a maximum of 2 HTTP gets. In order to do this, we put an index at the front of the file. We also had the A/B testable client was an innovation, and heuristics-driven adaptive streaming we introduced in Silverlight. And with that metric, the key metric is the rebuffer rate. And our A/B testing around adaptive streaming was all an attempt to drive down rebuffers. From the keynote previously, Damon had mentioned about the experience needing to be like TV. Well, there's a few things that we decided when you watch TV, if you change a channel, you don't sit and wait for 25 or 30 seconds while it says buffering. And if you're in the middle, it doesn't stop and say rebuffer, stop, rebuffer, nor does it skip, right? These were typical experiences of video streaming in 2007. When we introduced adaptive streaming, we decided that a user would rather have lower quality video that played continuously than high quality video that was constantly stopping, rebuffering, stopping, and rebuffering. And then also through the heuristics, you know, our A/B test was to maximize the quality. So we started out by, I'm here in the movie with all the bit rates I have. Let me look out to the end of the movie. Can I get there without a rebuffer? If I can't, let me try the higher one. As we moved forward, we thought, well, we don't need to do the whole movie. What if we do a 5-minute window, 10-minute window? You know, what if we do simultaneous, parallelize the range request? We did a lot of testing around things like this that really helped us to drive our adaptive streaming. After Silverlight, we implemented CE2 SDK, which was on a lot more Blu-ray devices, but also started showing up in connected TVs. It had a Flash UI, had adaptive streaming following the Silverlight model, unmuxed AV streams. Again, we're VC1, Windows Media Audio, but we added DD Plus for multi-channel, which was necessary in the living room. In this case, we're using WMDRM versus PlayReady, versus Silverlight that was using PlayReady. And we have an ASF container. Again, we put an index in front. And by the way, I will make these slides. The video is going to be available as well as slides, so there's nothing proprietary here. I'm happy to share this if you guys need it. So this is what we were doing, CE2 SDK. Again, it was a lot like the Silverlight implementation. This is where we brought adaptive streaming to the living room. Our next interesting, and this was probably one of the most absurd products that we did. First of all, how many people here are Netflix customers, by the way? And how many had a PS3 and streamed way back when you had a disc? Not very many. Okay, so we had an interesting situation with game consoles. The difference between a game console and other devices is in order to get on a games console, you have to have a relationship with the console maker, right? We negotiated that, or we worked that out with Microsoft, but it's not always easy to get your foot in the door. But we had this interesting opportunity with PS3 because PS3 was not only a game console, it is also to this day the most powerful Blu-ray player on the planet. It has an incredibly powerful CPU, and it has lots and lots of physical memory. So we decided to exploit the Blu-ray aspects of the PS3 in order to get Netflix streaming on the PS3. And another aspect of that was our deal with Xbox. We had a 2-year exclusive. The first year was no game consoles. The second year had to be a disc-based solution. And so we were going to be on a disc with PS3. This was a tremendous opportunity for us to get in. While we're still trying to get that relationship in place, this was an opportunity for us. So we decided to do this as a Blu-ray Live application using BD Java. We would exploit the progressive playlist feature. However, we had a requirement. Now that we had implemented adaptive streaming, we had a requirement that we had to do adaptive streaming in this Blu-ray client. Of course, it's Blu-ray, so we used H.264 or AVC video. We chose AC3 audio. It was the lowest bit rate we could get per the spec. And it's AACS DRM. We did have to have protected streams for our licensing agreement. And a key point to Vega, it was our first LOLAMO UI. LOLAMO stands for lists of movies. And if you use Netflix today, you'll see things because you watched Great White Sharks of the Barrier Reef, you might also like, and here's all these recommendations. That's LOLAMO. Or at least that's what we called it in 2009, and we exposed it through our API. A list of movies. So movies like this, movies like that, or you know, Western comedies, that type of thing. Those are all lists of movies. So the Vega stream format, per the Blu-ray spec, you can have 2-second GOPs. We divided each chunk into 3 segments of 2/3 of a second. These are MPEG-2 transport streams. We had a header file with an index. So this is what a stream looked like on the back end on the server. So we had an index that pointed to each 2-second chunk or each GOP, and then we had a sub-index that pointed into 2/3 of a second chunks. Remember, we're doing adaptive streaming, so we have to interleave audio and video on the client. So it's the same model for audio and video. The client, as in all of our streaming applications, the client pulls the headers at the beginning so that it can make the necessary decisions in the heuristics engine. So this is what an adaptive client looked like. Here would be 3 bit rates and an audio stream. The client will produce a local muxed file like this, and it can jump through those bit rates any way it wants. And then it will pass that to the Blu-ray engine using a progressive playlist feature. Because it's AACS, which has 6K block boundaries, we had to pad out audio and video out to 6K, which was incredibly inefficient. It put up to 30% bloat on our streams, but it worked. For the few people here who actually had the disc, you plugged it in, you pressed play, you actually got to watch your movie. It wasn't the most elegant solution, but it was actually adaptive streaming on the Blu-ray. On the PS3. So we had a few challenges with this one. The previous, we were always running on Microsoft technology. This is the first time we were, we had Microsoft Streams, Microsoft Packaging, Microsoft DRM. This was the first time we were off of Microsoft. These were incredibly complex streams. They're transport streams anyway. They have to be absolutely perfectly Blu-ray compliant or you can crash the player. We had this really bizarre model for adaptive streaming, muxing on the client, indexing, everything that we had to do to make it work. You simply couldn't go out and buy a third-party tool to do this work. And we knew that if we had non-conform streams, we're going to crash the player, and that would be a very bad experience for the user. We also had an incredibly tight schedule for encoding, packaging, and deploying assets. We started this in March, and we went live in October. So we were nothing in March and live in October. So we had about 6 months to do this. So this is how we did it. First of all, we wrote custom tools. All of our packaging tools were all done custom. We also implemented about 80% of the Blu-ray verifier tool in Java so we could run it in the cloud. So we could actually, when a stream came out, before we went live with it, we would take the full set and we would push it through a verifier and make sure that everything worked perfectly so that we wouldn't crash it on the player. This was also the first project where we moved our encoding to the cloud. Previously, we had been doing everything in a data center with physical boxes. This was, the Vega encoding was done in EC2, and it was our first. This was where the encoding tools team was started. So I was the first engineer, and now we have a rather large team that's responsible for all the encoding technology. And also the media pipeline, that's the larger distributed encoding system. It's our workflow that runs in the cloud. So I say they came of age. They were doing a lot of stuff before, but this was a point where we could spin up thousands of instances in Amazon and run encoding at a very high scale, which I'll be talking about again when we get to the iPad, which was on an exceedingly tight schedule. The 6 months seems like an eternity compared to the less than 60 days we had for the iPad. The next project, of course, we were really focused on getting on game consoles. So the next project was the Wii. And version 1 was codenamed Link. And again, it was a disk-based solution. So because at the time, we didn't feel that we could decode H.264, so we chose H.263 based on some working solutions. We also chose Ogg Vorbis audio, and the reason we chose Ogg Vorbis, again, was because we had a demonstratable solution that could decode the video and the audio, still with enough MIPS to do the rest of the application, keeping in mind that the Wii has no acceleration at all. And it's a processor that would be about year 2K in terms of power. So we used widevine DRM in this, and we stuck it in an ASF container with that ever-present index at front for the client to do the adaptive streaming. Now we've got all these devices. We've actually been successful, but with my encoding tools team, I'm beginning to look at what we've done. We're happy for the work we made, but this is what we're starting to see. We have our CE1 profile. We now have Silverlight, which is very similar, but it's unmuxed. We have CE2, which is almost identical to Silverlight, except it's using WMDRM instead of PlayReady. Now we have Vega and Link. And I always look down the road to see where we're going, and this is where I saw us going. And so, I'll talk about this more a little later, but early on we did what we had to do. But we're starting to get concerned by the trend here, and also, so we see, first of all, we see we have overlapping profiles. They're very similar, which was beginning to bother us, that why we have to double our footprint for nothing but DRM. In 2009, we were all planning for 40 million customers, which seemed, we had 8 million. 40 million seemed like a huge number, so the back-end teams were all told, you have to show us how you're going to scale to 40 million. As an interesting side note, we now realize that that was a really low target, so now scalability always has to be to infinite. So everybody, when they scale, they have to demonstrate that they can scale infinite. But at the time, 40 million seemed like a lot. And it was my best guess that 40 million would be about 120,000 unique viewables. I don't have any metrics to prove this is right or wrong. Some people disagree with me, but internally, but that was just my guess, that if here's on our customer trend, here's our titles we're going to track, this is about where we'll end up. And in 2009, when we had substantially less than 120,000, we actually had less than 20,000, probably about 15, we were about 25 to 50 terabytes per profile, and depending on the bit rates that we had. So obviously this bloat starts becoming a big problem. Now, in theory, CDNs can scale infinitely. In practice, they can't. And I'll tell you a quick little anecdote. So, we've also very successfully transitioned our business to the cloud. Well, my VP, we would have our all-hands meetings, and he had this really great graphic where somebody's standing out at the beach, at the ocean with a garden hose, putting water into the ocean. And that was our view of Netflix moving to the cloud and to CDNs, because you got this great infinite scale. We're just a little company, right? 6 months later, he changed that graphic. He had a little kiddie pool and somebody standing there with a fire hose, because that's what we really ended up feeling like we were. As we found ourselves saturating CDNs, we found ourselves saturating pretty much everything. So this is where we started working on a new profile where we wanted to try to get some consolidation. This is what we call CE3. We moved to H.264 is our primary video. Audio would be AAC and Dolby Digital Plus, the Dolby Digital for multi-channel. We chose to use a fragmented ISO container, and we chose to use the Microsoft PIF specification. This was in about August. We started working this in about mid-2009. We chose Microsoft PIF because it had a multi-DRM model that was we felt was very elegant. We wrote internal packaging tools around that, which has become a model. And this is what our fragmented MP4 CE3 version 1 looked like. It's fragmented MP4. You see we stuck a couple boxes up in front, and the key one is that Netflix index. Remember the 2-get rule. The MP4 model the fragmented has the index at the very end, but that would require a 3rd get, and that was not acceptable. So we just took that index and replicated it at the front. So now we have we meet the 2-get requirement, and we've got you can see the DRM boxes there. There's the DRM headers. There's a DRM box, and there's one at the sample level. So this is what we did for CE3 version 1. And then we just got that tooled up, and we got hit out of nowhere with this opportunity. So this was our challenge. On February 6, 2010, Apple invited us to be part of the iPad launch. It was April 3rd, 2010, so we had less than 60 days. HTTP live streaming was incompatible with Netflix in almost every way. There was absolutely zero. You saw we just had this great new CE3 profile that has nothing to do with HTTP live streaming. And I'll walk through some of the issues. But a week later, about a week and a half later, we had adaptive streaming working. And on 4.3, when iPad went live, Netflix was live, we had 20,000 titles encoded at 2-bit rates each. I'm going to talk a little bit. There was a little bit of luck, and some of the things I've talked about before actually put us right where we needed to be. It was rather serendipitous. So here's some of the issues we had. HTTP live streaming used an M3U playlist, but because of the nature of our content, the premium content, we have expiring CDN URLs. So they're constantly expiring, which means we'd have to be constantly generating playlists on the back end. And at the time, not that it's not doable, but it was just incompatible with our current streaming model, the back end. DRM wasn't a really well thought out in the iPad or in the HTTP live streaming. It was using MPEG-2 transport stream. We had just done all this great work on fragmented ISO. They have physical versus virtual chunk files. What I mean is, in our adaptive streaming, we have a single file, and we have an index, and that's virtual chunks. So the client simply does range requests wherever it needs to go to get the bytes. The original HLS spec, you had to break your file into physical chunks. They were muxed, we were unmuxed. So in order to adaptive stream, well, we'll talk about that in a minute, which is the precise audio alignment across chunks. So you're going to break this, you're going to have multiple video bit rates, have to be multiplexed with audio. And if you switch between the two and you have a slight misalignment of audio, we all know what happens, right? Users can tolerate a drop frame, but an audio pop is the end of the game. So these were all very big challenges for us. Starting with chunked files, we had to have precise alignment across all bit rates. It looks like this. Every chunk we make, every audio for every bit rate has to be the exact same across all of them. It's easy, I say easy, I don't think it's ever easy, but it's easier if you do the muxing on a single system. Here's all my videos, here's my audio, mux them all, and you've got to have some fairly complicated tool that's putting all these bit rates together all at the same time, trying to kind of follow this and keep everything correct. It's very difficult in a distributed environment such as ours, where we would take the audio in one video and mux it on one instance in EC2, and then we would do another bit rate on another instance, and we don't have all that state between them, right? So our workflow didn't support that. This is how we solved it, remembering that we were doing that on-client muxing on Vega. Looked something like this. Well, it just turned out that we could reach, and also one of the side effects of this was that this on-client muxing in our Vega Blu-ray Live solution yielded precise audio alignment. It was just an artifact of that having indexed audio and indexed video. So we just moved the muxer to the back end, and in about one day we actually had an HTTP live streaming muxer that would generate audio video stream with precise audio alignment. We took out all the Blu-ray pieces, basically just commented that out, but it literally took one day to produce a set of test streams. So we just took our Vega tooling and altered it slightly. On the M3U playlist, as I mentioned, it's very difficult with expiring URLs. So we added an index to these muxed files that we were producing, which has shown up a lot in our client models. And we just moved the playlist generation to the client. So the client starts out, grabs the headers for all of the streams he's going to use, generates an M3U playlist, and feeds that to the iOS playback engine using a local host. So iOS goes to get the playlist. It was generated on the client. So that's how we solved the playlist problem. Then the last thing we had was physical chunking, billions of files, right? Our NCCP service, that's our back end, was not designed for chunked files. When you do a movie authentication, it returns an URL for every bit rate. Well, we can't return 1,000,000 URLs, right, or 1,000,000,000. It was also troublesome for CDNs. You can't drop 1,000,000,000 files on an edge server. I mean, you can in theory, but you can't in practice. So our solution, going back to Silverlight, our Silverlight hack was a range request and an URL from Silverlight. So we already had this implemented on all our CDNs. We simply tricked Apple into thinking we were giving it physical files. In fact, we're giving it virtual chunks, and their player had no idea what we had done. It pissed them off, but it worked really well. So this is what an M3U playlist looked like in our initial iOS. And you can see we've just got the range request stuck out at the end. So here we had virtualized physical chunking for iOS playback. So here's a summary of what we did. We adapted our Vega Blu-ray live tools for HTTP live streaming. We did client-side playlist generation. We did range request and URL for virtual chunking. We actually got everything working, everything proven and tested 2 weeks before launch. And we went live on 4.3 with about 22,000 titles encoded at 2 bit rates each. A little interesting information there. If I remember, this number is not exact, but we had about 10,000 EC2 instances running 24/7 for those 2 weeks. We did 2 bit rates per title. And iPhone followed using the exact same model in the fall of 2010. The next client we did was PS3 version 2, which we codenamed Rigel. This was a native PS3 application. Our Blu-ray Vega application was very successful in getting us a relationship with Sony because now we had adaptive streaming on the PS3. Is anybody from Sony here, by the way? Okay, I'm going to get in trouble. So we end-of-life Vega. It was a great project. It took us, about 6 months to develop. It ran for a year, and then we shut it down. This was our first client to use our new CE3 profile. We're running PlayReady DRM. Whoops. And then we came out with Wii version 2, which was codenamed Kirby. This was a Wii Store application. We're still using H.263 or MPEG-4 Part 2 and Ogg Vorbis audio, but we moved to Fragmented MP4. We were using the PIF file, same as CE3, but this was not considered a CE3 stream, using PlayReady DRM. Now I moved to CE3 Profile V2 because at about the time we were rolling out these applications, the Dash committee was formed, and we started having a lot of work on standards-based player. And by this time, we were very much interested in moving towards a standard-based player, right? We've done a lot of work, we've got a lot of great developers, but we see the value in being able to just have streaming ubiquitous, where we could focus on the service. So we joined Dash in 2010, and one of our key motivations was PIF Dash compatibility. We know that Dash was going to be on Fragmented MP4, they were heading that direction. We already had all these devices locked into PIF, so we're hoping we could get a compatibility model where we could actually have one set of streams that serve both. And actually the outcome of that, we were able to, through Mark Watson, who's at Netflix, who was able to propose a very elegant model where a stream could be both PIF or DECE compliant and Dash compliant. So this is what we did. This was a picture I showed you earlier of our CE3 V1 streams. We just moved this way. We added a Dash CIDX, which is an index. We stuck our index at the back, and these are the Dash boxes we added in. So we were able to make this and test it on our existing clients, and it played back fine. So they were able, without duplicating our profile, we're actually able to go back and remux our library, and now we have both Dash and PIF compatible streams. Some of the CE3 V2 clients would be Android, Roku 2, and now Xbox, PS3, Wii, and Wii U are all running on our Dash streams. So here's a summary of our profile evolution. which we've seen part of it. We started with CE1, muxed, ASF, WMA. We went to Silverlight, which was unmuxed with PlayReady. CE2 was unmuxed with WMDRM. We did Vega, which was an odd implementation, H.264, AC3, Blu-ray compatible. We did our Wii V1, which was H.263 and OGG. We eliminated Silverlight and Vega, moved those two to CE3 dash. We eliminated Link V1 and moved to V2, which was from ASF to Fragmented MP4. We then added OGG Vorbis to our CE3 profile. We eliminated Kirby PIF and moved the Wii to H.264. In the 2 years, we'd actually were able to demonstrate that it was possible to decode H.264 baseline on the Wii with sufficient MIPS to still get the audio and handle client. So we were then able to get rid of, so this is where we ended up. Of course, we have iOS 1, which is muxed MPEG-2 transport stream. More recently, we added iOS 2. You guys are thinking I got this shrunk down. Now it's all starting to grow again. iOS 2, which is, they now support unmuxed, and they support virtual chunking, so we don't have to have the tricks anymore, or the hacks. We've deprecated V1 because most devices now support the V2 streams, and so it's just the older, like the iPhone 3.1, the original iPad, actually the original iPad and some of the old iPods. So we deprecated that, so we're able to get rid of a lot of the bit rates. I mean, in fact, when we went live in Latin America on iOS, we were on V1, which meant we had to have a separate mux for every language as well. So not only did we have the bit rates, but we had like Portuguese and Spanish, which would like triple our footprint. So we're able to bring all those down, move that all to iOS V2. We're now looking at what we call CE4. This will be a new profile, and this is going to be around H.264. I'm sorry, H.265 or HEVC, which for Netflix, it's all about Ultra HD. We would continue to use the audio from CE3. There's no reason to change that. And I mentioned that's as planned. So let's summarize our progress of the history of Netflix. We started very simple, just the Internet Explorer plugin. It gave our executives and the back-end, the internet teams opportunity to collect metrics and to start doing projections. We had a very incremental evolution. Silverlight was our first innovation platform, and it was not just innovative, it was a platform for innovation. Even to this day, we use Silverlight because we can do really great and quick A/B testing on Silverlight. Our early development model was go to device. We literally, as seen by the Blu-ray hack, did whatever was necessary to get streaming up on a given client. We literally would do anything. We didn't care about footprint. We didn't care about profile or complexity. If we could make it work reliably, we would do it. Now we've moved into a standards base. We're not interested in trying to just, and it's really not necessary because the whole device, the video playback ecosystem has evolved along with Netflix, and so it's not necessary. So we're really now looking at standards-based streaming solution where we have to do less of that, less of the client-side work. We have a very agile development model, as demonstrated by the iPad. 60 days, less than 60 days, basically all of Netflix turned like a laser. I kind of like the great eye in The Lord of the Rings, when you got Sauron's interest, that eye just focused in on you. When our CEO gets that interest or we see an opportunity, the company will turn and shift and put everything into it. And it's also the Netflix model of hiring very well and very experienced so that when you get problems like this, you don't have to spend 6 months planning. You simply put your best people in a room and have them work it out and come up with a working model. Very quickly, you get a working model, you test it, and then you bring it to market. Of course, we hack when necessary, again, as evidenced by the Blu-ray application. When all else fails, hack. I also want to point out, I've given you a history of Netflix streaming from a video encoding guy, right? All about codecs, profiles, containers, DRMs. There's a tremendous amount of innovation that's happened at Netflix that's totally outside my domain that I would not be qualified to talk to. UI, heuristics, the back-end scalability, the cloud, everything that we've done, even the Open Connect, our new CDN model, all these things are just tremendous innovation of which I'm really not qualified to discuss. I do want to point that out, that there was a lot of innovation that happened in other teams in order to make this very rapid 5-year evolution possible. At this point, I'll open it up for questions. I do want to point out there's my email address. Feel free, if you have any follow-up, feel free to shoot me an email and I will answer you. Yes, sir?
How big is your development team?
How big is my development team?
And the associated development team that you just accredited.
Okay, so, well, we're all in Los Gatos, and we have more than 700 engineers in Los Gatos. Or I say engineers, the engineering organization, including managers and directors, is in excess of 700. Now, I'm on the media pipeline team. My director is owns all media pipeline, which is the entire encoding solution, the distributed encoding solution in Amazon. And then from there, I'm the encoding tools team underneath that. And so the larger pipeline team is at about 35. My team is now we're at 7 and hiring. Yes, sir.
You used Amazon EC2 because you had to scale fast. Have you ever looked at the cost difference if you had built inside infrastructure?
So the question is, we used Amazon EC2 because we had to in order to scale fast. Have we looked at the cost difference if we had done inside? And the answer is yes, because prior to Vega, all encoding was done in a data center, and we were just continuing to build out data centers. In addition, the back end, all of the web services, everything was also done in data centers. Lots of big iron, big systems, big databases, and it's simply, if you did the math, looking out at our customer growth, it simply would not scale. Not only was it prohibitively expensive, it was just not possible. You can't get 100 million customers all tied into one big monolithic database, right?
For the iPad 1, you said you released 2 bit rates. And how many bit rates are you serving now? Or can you give an idea about the range, the 2 bit rates do you think customers have?
Okay, that's good. So the question is, with iPad 1, we started out with 2 bit rates, and how many bit rates do we have now? Well, we started with 2 bit rates because even with 10,000 instances, that was all we could get done in 2 weeks. And if I remember correctly, because I actually had gotten my tooling ready, they spun it up, they ran almost like half the catalog, and we realized we had a bug in my tool. So I went home one night like, oh crap, I just wasted $100,000, and I thought I would be fired, but I told my VP the next day, I'm sorry, I messed this up. His comment was, look, we're on the bleeding edge, right? This is a cost of life on the bleeding edge. We did those 2 bit rates. We added in, we basically filled in. So for the iPad originally, that was all done baseline. So the bit rate started at 100. We started at 100 for wireless, for 3G, and we went up to 1350, all baseline. When we brought in the Apple TV, we added in the main profile, which we had already done in CE3. Starting at, we've gone down as low as 260, but our testing has shown us that quality is just too low, and users abandon. It's just too blocky. 360 to 560 is good enough. We can start up fast enough, and the customers will stay engaged for the 10 or 20 seconds it takes to switch in. So we start, really, you should think about 560K, and then we go all the way up to 1080p up in the 5 megabit range. And that's incrementally up. Our highest SD bit rate is 1750. We go 720p starting at 2350, and then we get to 1080p at about 4 meg. Him first, his hand up a lot.
I know Netflix claims that they have over 850 or 900 unique device types that they service today among all your subscribers. How do you manage your workflow, given what you just described in terms of what you have to do on the back end?
I'm sorry, how do
you manage your workflows to support
Okay, the question is a good question. With so many different devices, how do we manage the workflow? A lot of those devices fall into buckets, like Android, right? Which wasn't the case early on. Early on, Android required in some way or another something unique for almost every different brand. But now the Android streaming layer is pretty good and consistent. So you have Android. That's a lot of devices, right? I mean, that really kind of pushes that number up. You've got the iOS family, right? It's the same streaming model for all those. You've got all these connected TVs, and this is not cooperating. I'm just going to unplug it. If anybody didn't get my email address, you can just come up and I'll give you a card. So, and then we have the connected TVs. We actually have an SDK we give to the vendor. They do the implementation, and then they bring the device back to us for certification, for compliance certification. So it's not nearly as bad as you think. Now, granted, it would be hard for a small company to replicate that, but with the move towards standards-based playback, it won't be necessary, right? We were like a pioneer in this space, and so we kind of had to, we had to plow our own trail. But at this point, it would not be necessary, I think, to replicate that. And as more clients are moving to standards-based playback, it'll be easier for other services to get onto a broader set of clients. Yes, sir.
Yeah, I had a question about workflow too. And you guys get some funky old content in there, like stuff that it looks like sometimes you took like a VHS tape. You know what I mean? And then, so can you tell me more about how you get content from your sources, and then, or what format it comes in? It seems like you get it in a lot of different ways, and how you put that then into your, must be a really rigid transcoding or encoding process.
Okay, so the question is around, let me see if I get this right. We get content that's very old, oftentimes as very recent, and the question is, how do we get that into our system and get it to some consistent streamable quality? And I'll tell you, it is a challenge for us because the old content in particular is not conformed to anything. I mean, I don't even know what tools were used to produce some of this stuff. You can't imagine. It's like you can open up with analyzers and it's just like tens of thousands of errors in a transport stream and such. And there are some streaming services, that they require that here's our spec, for instance, the iTunes, and you must meet that spec exactly. That's one extreme. There's another extreme that says, you give us whatever and we'll try to put it through. And that's been our model, is give us something, and if it can get through, we'll take it. However, that's not scaling. And so we're now trying to find some place in the middle. We don't want to be like, you must meet this exactly. But we want to try to find a place in the middle where you give us stuff, it has to be conformed. Like if it's transport stream, it's got to run through an off-the-shelf analyzer and come back with no errors, right? It can't be. And so we're trying to move that, but we're also doing it very differently in that we feel like I'm not really fully qualified to talk about the post-house production, all that. We have another team for that, but we are really trying to get their process to scale, knowing that it doesn't just benefit us, it benefits everybody, but if it benefits everybody, it benefits Netflix. And the way to do that is to start getting people to conform to standards. We're having the same problem, not just with streams, with captions. In fact, captions are even worse. You'd think it's just a text file, right? But the captioning world is all over the place. So that is a challenge we have right now, and we do have a lot of assets that we've had for a while that are very difficult to work with. And yet we just had to handle those internally. But going forward, we're saying we've implemented some good inspection tools, and when stuff comes in before we receive it, it's got to pass some inspection and show that it's conformed to a reasonable specification.
My last encoding question, do you guys use CBR?
Encoding question, do we use CBR? No, we use VBR. And just if anybody's curious, X.264 is our reference. We don't always use it. We also engage with third parties, but we use X.264 as the reference. So that's what all comparisons are done against. Yes, sir.
On an early slide, you mentioned that rebuttal rate was one of your key metrics for the user.
Uh-huh.
Is that
So the question is rebuffer rate still the driving metric? Are there other metrics? Well, there's all kinds of things we test around. Like for instance, we tested around playback start. And what happens if we drop down to 200 or 250K on a CE device instead of going at 560, which was our normal first stream? Rebuffer we feel is the most important, because if you're going to be successful in the living room, if you're going to not replace TV but augment TV, Netflix does not want to replace TV. You have to behave like TV. You have to give a TV-like experience, right? And again, as I mentioned at the beginning, you don't change a channel and wait for 25, 30, 45 seconds for the show to start, and you don't sit there in the middle of the show and have it constantly stop and gap and pop and rebuffer. So that is still our key metric, because nothing will stop it. I mean, what we're interested in is retention. A user presses play, do they stay and watch it to the end, right? Because the longer the customer watches, the more satisfied they're going to be with our service, the more satisfied they are, the more likely they are going to stick around. So we found that rebuffering is, you start rebuffering and have long startup times, that will get customers to back off and abandon playback very quickly. Yes, sir?
I know you guys are really good about open sourcing tools. Are you planning to open source any of these analyzing tools?
Yeah, we're actually working on that. We're working right now because our biggest grief is with captions, and particularly with everybody moving to TTML and doing so very poorly. We're working on an open source TTML validation tool that's which would be SMPTE based. We are, as far as our internal tools, that's always a possibility. I now have a much larger team. A lot of the early development I did myself, never thinking other people would actually look at my code, so would have to do some work there. But I do feel there's value. But there's also, like for the post houses, we try to steer them to some really good third party. The problem is, if we open source, then we have to start supporting. And for instance, we have a transport stream analyzer, but it's not as good as the ones you can get from Manzanita or Tektronix or others. And we're never going to be that good. We just look at the stuff we know chokes up our system. So we would rather have our providers using a really high quality analyzer off the shelf. They're not that expensive, and that way they know they're producing conform content. Because all we're looking at is, well, is this good enough to get through Netflix system? And if you can pass a Manzanita or Tektronix analyzer, its transport layer, it will get through our system. Yes, sir?
What are the factors that would signal you to see that it's ready to move to H.265?
What are the factors that will signal us to see it's ready, that it's time to go? We like what we're seeing so far. We've had several codec vendors have engaged with us and are showing the progress they've made. We're impressed with the quality. We're impressed with the encoding performance. Not that we're not really interested in how fast you can encode, because we have very long lead times on our stuff. We're more interested in quality. But the reference H.265, we did a 2-minute test clip. It took 4.5 days, right? So though we're not totally focused on performance, there is some performance that's just too bad, right? The cost would be prohibitive, but we're happy about what we're seeing in terms of quality and the performance. And for us, 10 to 30 times real time, we would consider it. 10 times at the low bit rates, or 3 to 10 times at low bit rates, up to 20, 25 or 30 at the highest bit rates, we would consider acceptable performance. So 30 hours for a 1 hour content. And then also, I mentioned Ultra HD. We really see HEVC as the vehicle for Ultra HD, which is the high frame rate, high color gamut, and the Rec 2020 color gamut, and the high resolution, which almost 4K.
When do you envision some of those factors will be ready for prime time?
You see how fast we work. So I'll just say it'll be sooner than you think.
Are you concerned about the lack of interlace tools and 3-2 pull-down detection in HEVC? Because I imagine 95% of your content's sourced in.
So the question is, are we concerned about the lack of interlace and 3-2 pull-down? The answer is no, and because very little new content is being produced interlaced. In fact, I don't know that any is. I know there's still directors using like film, but I know anybody who's doing interlaced. And we feel H.264 is perfectly suitable for old catalogs. And we assume that any device, and actually on the Netflix side, any device that was certified for HEVC will also have to be able to play H.264. So we would simply, if the titles we didn't, and if we just didn't feel it was worth it doing HEVC for a given title, then when they make a request, they'll get the H.264 streams. So we really kind of see it that way. At some point, I mean, interlace goes all the way back to a farmer, Philo Farnsworth back in the 30s, right? And cornfield. I don't know if anybody knows that. He was running a tractor in his cornfield. They couldn't get a whole frame in through the TV signal, and he had a 16-year-old farm boy had this great idea watching with the tractor like, hey, wait a minute, And so they came up with interlace. And so here we are. That was in the 30s, right? Here we are like 75 years later. We're still dragging this with us. So I feel HEVC is a great place to make that break. H.264 is great. It'll handle that, and it's going to be a long time before clients won't play H.264 content. Yes, sir.
Yeah, obviously you're using file-based sources for all of your new encodes, but I'm assuming that for your older material you had to encode from baseband. Were there any challenges with that? You probably had a variety of videotape sources as well as disk.
So the question is on the source type, file-based versus tape, and that's others. We've always engaged through post houses. If we didn't get it as a file directly from the content owner, then we would have a post house do the work for us. We don't have any workflows for like taking tape to digital or anything like that. Look at somebody in the back. Yeah, you right there. I'm sorry, I couldn't hear you. No, it's okay.
So you mentioned standards-based profiles, and I'm wondering if your CE3 profile is completely dash compliant.
The question is our CE3 completely dash compliant? And the answer should be yes. There's only one standards-based player that we know of that's using our streams. There is only one using our streams, and it is actually working. So we're not using, at this point, we're not using the dash playlist. We're only using the streams. But to our knowledge, and with all the available tools, which are fairly limited for compliance, we're pretty sure that we're dash compliant. And dash was actually not a big step from PIF, right? It's just a few extra boxes. So if anybody has had any testing that would suggest otherwise, please let me know, because I would be the one that would be responsible for fixing that. Yes, sir?
What's your preferred format for 4K?
My preferred format for 4K? This really scares my team. We're looking at files that are basically just a collection of JPEG, and we're hearing numbers like 4 terabytes an hour and stuff, and so we're kind of freaking out on how we're going to handle this scale, but that's what we're going to be looking at. So we're going to get closer. As the quality is going up, we want to get closer and closer to the original format. We're finding that if you, for instance, if a post house gets a high quality and then they turn it into an MPEG-2 transport stream, we've just suffered a quality hit that we're no longer interested in taking. So we're pushing our way back, and it is a little concerning in terms of scale. When we're, again, even like my team, if we have to triage an issue or diagnose, we've got to pull a mezzanine local, but our typical engineering systems only have 3 terabytes or 4 terabytes, and then we're talking about 4 terabytes an hour. So we're wrestling with these numbers. Yes, ma'am. So the question is, over the years, we've moved through different formats, and do we always go back and use those other formats? Yeah, I mean, we still have millions of Roku 1s. They're out there streaming CE1, and we've got connected Blu-ray players, and so we'll be producing those streams for the next 10 years, I suppose. There may come a point where we can say, okay, here's a few users left. Let's send them all a new device or something, but there's still a lot of devices. Yes, we have to encode it. Like we'll encode VC1, which is unique, and then we do the H.264 once, and we package it for iOS. We package it for CE3, right? So we package it multiple times, all the way in the back. Do we have a way to solve the CDN switching for HLS? Yeah, we worked around it. Again, iOS, the original, as it was conceived with the, on the surface, chunked files, muxed audio, video, all sounds very simple. In terms of scale, it's a very difficult model to work with. We simply did not feel it would scale. You don't get caching efficiency with all those files. You know, so we just had to work around it. You know, through all our years and all the work we've done, we've found that virtual chunking on single files, they cache out to the edge very well, and people are doing the same range request, which means the CDN service is going to optimize around that. And so that's our model, and we're trying to push everybody to see things that way, right? We believe it's the right way to do adaptive streaming. Any more questions? Great, well, thank you very much. I'll stick around if anybody has anything they want to ask me afterwards.